Okay, so let's continue part 2. We are talking about absolute value functions because absolute value functions are piecewise functions. They're just usually not thought of in that way. When you were in middle school, you used to think absolute value functions were probably like the easiest thing to deal with ever because all you had to do was take the number on the inside and make it positive. So I have a little middle school definition there just to make you laugh, but of what I think absolute value seems similar to. Anyway, the absolute value function, we're going to kind of make a formal definition of what this is real quick. So let's see what we've got. So it says, if a is greater than 0, then the absolute value of a is equal to what in terms of a? Well, if a is greater than 0, then the absolute value of a will just be whatever a was to begin with, because this means that the a value to begin with was a positive number. And we know if you have a positive number inside an absolute value, it's just going to be equal to that number, right? What if the number you plug in is negative to begin with? Then the absolute value of that number you're plugging in is not going to be equal to that number, right? It's actually going to be equal to the opposite of that number. And the opposite of that number would be a negative to represent the meaning of opposite. There we go. Here's an example if that's too confusing. Let's pick a number. So let's say a is negative 3. And let's say you plug negative 3 in to your little absolute value, right? And we all know that the answer is 3. This negative sign that we have written here in this formal definition doesn't mean that the answers are negative. It means that the answer is going to be the opposite sign of the a value that you plugged in. The a value we plugged in was a negative 3. The outcome was a positive 3. So this negative sign right here just means opposite of what you plugged in. Okay, so that's important to understand this connection, not because you're going to be tested over the formal definition of absolute value, but so you understand that an absolute value operates in 2 different ways depending on the type of value plugged into it, which is essentially a piecewise function. That's what we're defining, is a piecewise function. So what does an absolute value then look like as a piecewise function? Well, we're going to draw that here. So the input of any number greater than 0, so we'll call that x. It was a on the last slide, but anything greater than 0 is going to be the same exact outcome, right? So we have all these points on my graph, 0, 0, 1, 1, 2, 2, etc., that represent the positive numbers being plugged in, and then when you take the absolute value of that, you get the same outcome. But on the other hand, if the number you plug in, which we called a on the last slide, is less than negative or than 0, then the outcome after you take the absolute value of this number is going to be positive. So graph those points, and you have a V-shaped graph that's going in the opposite direction now on this side as the other side, okay? What we want to do then is come up with a piecewise defined version of the absolute value function. Well, we have a graph. What I mean is I want to write an equation for this. So the equation would be representing both sides of this V-shaped graph. So I'll start with this right side. This right side looks like it has a slope of 1, and it's starting at the origin. So the equation for that would just be x, because the slope is 1 and you're starting at the origin. And we're going to write a domain restriction over here saying that this is the equation whenever x is greater than or equal to 0. And the left side looks like it has a slope of negative 1, but also starting at the origin. So we would call that negative x. but that side only occurs when x is smaller than 0. So we have a piecewise function to define our absolute value graph. Okay, back to all these review things. So last year we talked about even and odd functions. So let's start with even functions. Even functions visually display y-axis symmetry. Even functions, y-axis symmetry. So the most common even function is like a parabola, or this is an example down here. It's, I think, part of a sine wave, but even functions display y-axis symmetry. Odd functions display origin symmetry. So this would be like your x cubed function, your reciprocal function. I'm sure there's others I'm not thinking of right now, but those are a couple that come to mind at the moment. There is a more formal definition of both of these up at the top. So an even function basically says that if you plug a negative value in for x, you will get the same y value as if you plugged in a positive number. Let me go to the graph and try to explain. If x is a negative value, here's the y value, right? We call that f of x or f of negative x. Here's the positive version of that same x value. It has the same exact y value. That's how even functions work. They're symmetric, so one side is equal to the other side. Odd functions are going to be the opposite. So an odd function is if you have an x value that's negative and an x value that's positive, the signs, see the sign up here on the outside? The signs of those two y values are going to be opposite. Okay, so on this graph, if you look at your negative x value, here's the y coordinate. It's down in the negative side of y's. And if you go to the positive x value, the y coordinate for it is up. So maybe this y coordinate, or maybe this point, I don't know, is -2, -4. If this is an odd function, then I know that this point would have to be 2, 4, because it has to show symmetry. It's just symmetric through the origin in this case for odd functions. So you're going to be expected to have to figure out whether functions are even, odd, or neither using only an equation, which is harder to do than just looking at a graph. So here's what you're going to do. You're going to test it. So you're going to take your x values and you're going to plug in a negative x value for every x you see in your equation. Okay, and here's how that looks. So I'm going to plug a negative x in everywhere that I see an x. That's step 1. Step 2 is you are going to simplify what can be simplified. So right here, if I say what is negative x to the 5th power, or if I take a negative number and raise it to the 5th power, your outcome would still be a negative number. So I'm going to call that negative x to the 5th. And then obviously plus a negative could just be written as minus, right? And then the last step is going to be to see, did the signs change or did they not? If the signs don't change from your original function, meaning this thing up here, your signs don't change, then you have an even function, because that would mean your y values are equal. If all your signs change, that would mean you have an odd function because all the signs have flipped. So you just have to make sure that what you have, which what we have here is it appears that the signs have all changed. You have to make sure that it's equal to negative whatever you had to begin with. So if I were to take a negative out of that entire equation, it would look exactly like what we started with. So this would be an odd function. let's try that again because that's a little tricky. So I'm going to do the same thing I did before. I'm going to start by making all of my x's negative. And I'm going to figure out what kind of sign I'm going to end up with here. So I have a negative number being raised to the 4th power. Well, a negative number raised to the 4th power would become positive. So this negative, this one right here, would go away. And I would be left with 1 minus x to the 4th, which is the exact same thing that I started with. So this would then have to be an even function because the signs did not change. Last one. Same steps begin. Plug a negative x in everywhere that you see an x. Solve. So the first part, 2 times negative x, that's negative 2x. Over here, what's a negative number become when you square it? It becomes positive. So that would just be minus x squared. Compare. Compare to the beginning. Well, the signs changed, but actually not all of them. The negative, or the 2x at the beginning became a negative. So I guess I could take a negative out of every term. But then what I'm left with is not the same as what I started with, right? So some signs changed, but others didn't, and that's not a consistent pattern. So this would not be either or even or odd. This would be a neither. This means it doesn't have any special symmetry. Okay? Couple other things and then we'll be done. So increasing and decreasing, remember that we need to be able to describe when a graph is increasing and when a graph is decreasing. This one is a nice example. This graph is increasing from A to B and from C to D, and then it's decreasing from B to C. So make sure you know how to explain, just kind of show a little domain of when a function's increasing or when it's decreasing. There's a formal way to describe these things, and we're going to look at that description briefly. So basically what's happening is we're going to look at this increasing part from A to B. At this point, we're going to call that x value x1. And we'll go look at this point as well, and we're going to call that x value x2. And what's true, what we know to be true, is that x1 is smaller than x2, right? Because it's closer to the origin. So x1 is smaller than x2, okay? If my function is increasing, that means that the y value at x1 must be smaller than the y value at x2, right? And so if the y value at x1 is smaller than the next y value, then you have described an increasing function. Okay? If you flip that, if the first y value is lower, I'm sorry, if the first y value is larger than the next, then you are describing a function that is decreasing. If your first y value is taller than the next one, then that is a decreasing function. Okay, that's it. Obviously, if you have questions, we can answer those in our next class period. Whenever I see you next, you do have an assignment in the book over this section. Those problems are listed here, and they'll also be listed on Classroom.